right, hello. So today we are on day 4. We are talking about molarity and dilution. So we are starting by talking about concentration. So concentration refers to the amount of substance per defined space. So pretty much the amount of your substance in a given volume, okay? Whenever you looked at your curves from last class, this was always per 100 grams of solvent, right? So if you remember your curve, it was always per 100 grams of solvent, of water, okay? However, whenever we do solubility and talk about it and use it in calculations and problems, we rarely ever refer to solubility in terms of grams per 100 grams or anything like that, like the solubility curves do. Instead, we use this thing called molarity. So molarity is a unit that we use to refer to the concentration of a substance. And molarity is the number of moles of solute per liters of solution. SLN is solution. Okay, so you have two different formulas that you can use to calculate this just based off of what you have. First is just simple moles divided by liters. So N, if you remember, represents moles. Since molarity is moles of solute per liters of solution, you are literally just dividing moles by liters to get molarity. If you don't have moles and you have the mass, you can do your mass divided by molar mass divided by liters. Now, if you don't like this big thing, that's okay. You can also take it and break it up into two different things. So you can do your mass, molar mass, and then 1 mole to get moles, and then divide it by liters. So you can, this is taking these two separate steps and putting them together into one. Yes? Okay. So if you're looking at this and going, oh, that seems like a lot, you don't have to do all of this together. You can do just your traditional dimensional analysis to go from mass to moles. And then once you found moles, you can divide by liters. The unit for molarity, they're the same thing, but it's technically two different ways that you can write it. Molarity, whenever we refer to molarity, we're solving for capital M. We can also use capital M as our unit. Refers to molarity or molar of the solution. However, molarity is also moles per liter. So you can write it as capital M or moles per liter. And it's really important that you know that capital M molarity, that's the same unit as moles per liter. Okay, these are the same thing. Questions? All right, so if we have 2 moles of potassium nitrate and it's dissolved in enough water to make 1 liter of total solution, we're going to say that the concentration of the solution is 2.0 m or 2.0 moles per liter. Or we could also say that we've got a 2.0 molar solution. So whenever I talk about molarity, molar is essentially the way that you verbalize it. So you'd say a 2 molar solution. You wouldn't say a 2 molarity solution or a 2 mole per liter solution. Okay? Occasionally you will see it written. It just means they're all different ways of saying the same thing. All right. Since molarity is the way that we express concentration in chemistry, an increase in molarity, okay, what do you think that's going to tell us about the concentration of our solution? If we increase the molarity, what happens to our concentration? Yeah, it's going to be more concentrated. And so a decrease in molarity means that our solution is going to be less concentration or more diluted. So more diluted or less concentrated, same thing. All right. So, how would you make a solution? This is something that you need to know. I will ask you on your assessment what you would need to do to make this particular solution. Okay? So it might be a multiple choice. In fact, I don't think I'm going to ask you to specifically write out each step, but you will be given like a multiple choice, and you'll have to choose the correct way to write, or correct way to make this solution. Okay? So, how are you going to prepare a 1 liter, prepare 1 liter of a particular molar solution of a solute? Well, what you have to use, non-negotiable, is a volumetric flask. Okay? Anyone happen to take a guess as to why we have to use a volumetric flask? Yeah, nothing else is accurate or precise enough, right? Volumetric flasks are your most precise piece of equipment, because what's so special about them? Yeah, they have one singular line, one singular marking on them, because they have been made to exactly and precisely measure that one specific measurement. So, we're going to use a volumetric flask because whenever we make solutions, we are making a particular volume of solution. Okay? Now, what are you going to do? Well, you've got, if you're using a solid to make your solution, first thing you got to do is, if you know your molarity, okay, you're going to calculate how many moles you need. So we can do Rm equals N over L, right? If we know that we have a particular molarity we're looking for, so let's say it's 2, and we know this is 1 liter, well then that means I'm going to need 2 moles of my solute. Now, can you measure moles in the lab? Like, is moles something that you can measure in the lab? No. What do we measure in the lab? Grams. So then you're going to have to calculate how many grams you need for how many moles you need. Yeah? Okay. So obviously that amount is going to change based off of what your substance is and how many moles you need, okay? But you're going to mass it out, and then you're going to add it to your volumetric flask that's already about halfway filled with water, okay? Now, the size of your volumetric flask is going to depend on the volume of your solution that you are making. They make volumetric flasks in a variety of sizes. We've got 250, 500, 1 milliliters, 1 liter, 2 liters, okay? So you're going to choose the correct flask based off of the amount of solution you need to make. You're not going to choose a 1 liter flask if you only need 500 milliliters of solution, because you have no way to know if you are precisely measuring out 500 milliliters. Okay, so you are going to add that to a volumetric flask that's already got some water in it. Okay, this helps keep that solute that you're adding from kind of clumping up on the bottom if you've already got some water in it. You're going to add it and then put it on a stir plate and mix it up. After that, you are going to add distilled water up to the line. You've taken out your stir rod if you put one in there, okay? But once it's all mixed up, then you're going to add water back in up to that line. Anyone want to take a guess as to why we didn't add up to the line in the first place? We didn't add all of our water and then added our solute. Yeah, our solute is going to take up some volume, right? So if we fill it up to the line with just water and then we add our solute, we are going to end up with a solution that is larger, that is more than our 1 liter, or however much we're trying to get to, okay? This is especially important if you're using a liquid solute, right? So this here, it's really important that this, the 1 liter, it's 1 liter of solution. So that is the full solution with your solvent and solute. It's not just 1 liter of solvent plus solute. Yes? Okay. So Looking here, how many grams of sodium hydroxide must be used to make 500 milliliters of a 2.5 molar sodium hydroxide solution? How are we going to calculate grams of sodium hydroxide? What can we do? Perfect. We can calculate moles and then convert to grams. How are we going to calculate moles? What are we going to use? Yeah, we can use our N over L. So we can use this formula and then convert to moles, or we can, and convert to grams, or we can use this and then just solve for mass. So you can do either one, okay? So we can do this. And so we would do 2.5 molar equals N over, what goes on the bottom? Perfect. 0.5 liters. Because your molarity is always per liter. It is not per milliliter. So if you see milliliter, you got to convert. Okay? So then you're going to plug that into your calculator. And what are you going to get? 1.25 moles. Okay? Now that we've got moles, what can we do? Convert to grams. How? Molar mass. So we're doing sodium hydroxide. I'm just going to go ahead and tell you the molar mass of sodium hydroxide is 40 even, so 40.00. Is that going to go on the top or the bottom? Top. Good, because that's the 40.00 grams. 1 mole on the bottom. So then how many grams of sodium hydroxide? Good. We're going to use 50 grams. And with sig figs, it's going to be 50 decimal grams. Because this 2.5 molar, that's 2 sig figs. So 2 sig figs. If you did 50.0, because 500 milliliters is 3, I'm fine with that too. Okay? All right. How would you go about preparing this solution in the lab? So what would be our first step? What do you think we need to do? Yeah, mass out 50 grams of sodium hydroxide. Okay. What are we going to do after that? Fill the flask, how? Yeah, about halfway. What flask? What size volumetric? 5.5 liters or 500 milliliters? We're making a 500 milliliter solution, so we are not going to use a 1 liter volumetric flask. So we're going to fill a 500 milliliter volumetric flask around halfway. Do we have questions? Okay, I just want to make sure. All right, what are you going to do after this? Good. We're going to add our sodium hydroxide and mix. Are we done? Good. We're going to fill up the flask with water. Flask with water to the line. And mix again to make sure that we've got all of that water mixed in with the sodium hydroxide solution that we've already made. All right, questions? So you need to know that you're using a volumetric flask. You are not filling up the flask until the end. Yes? Okay, those are the two big things. Fill up the flask at the end, and you're using a volumetric flask that matches the volume of your solution. Okay, cool. All right. If 35.8 grams of lithium hydroxide is dissolved in enough water to make 750 milliliters of solution, what is the molar concentration or the molarity of the solution? What are we solving for? Molarity. So what formula do we need to use? N over L. So we can either do N over L, or since we have grams, you could also do mass over molar mass divided by liters. Now I do want to point out something, because I realized I didn't earlier. On your formula chart, if you look under solutions, the molarity formula is that first one. It says moles of solute over liters of solution. And it even tells you that moles represents N. N represents moles, okay? So you do not have to memorize this formula. The other formula, mass over molar mass divided by liters, is not on here. However, if you happen to look under behavior of gases right up above, you can see that N is M over MM, so mass over molar mass, right? So we can take this mass over molar mass and place it where the N goes. We'd just be replacing the variable, okay? So while this second formula here is not explicitly given to you on your formula chart, you can use what's on your formula chart to figure it out if you like that formula. And I'll tell you right now, there's not a formula this unit that isn't given to you on your chart. Okay? All right. So then go ahead and solve for molarity. So those of you watching the video, pause and then come back and check your answer. Okay, so the answer is 1.99 molar. So you could have done it one of two ways, and I showed both ways that you could do it. So if you chose to use this first formula, you would have just done a quick little dimensional analysis to get your moles, and then you would divide it by your liters, get you 1.99. If you use the combined formula, you're basically just putting it all together, and you're going to do the exact same math. Questions? All right. So those of you watching at home, pause the video again and try the next example. All right. So this is your answer. You should have gotten 1370 milliliters. So these are the two separate ways that you could do it. If you used your N over L, you would again, go from grams to moles. And then, hey y'all, thank you. You would go from grams to moles, and then you would plug it into your molarity equation. Your moles over liters equals 0.500 molar. Solve for L, so you would do your 0.684 divided by 0.5. That gets you 1.37 liters. But I asked for milliliters, so multiply by 1,000, 1370. You do not have to show me multiplying by 1,000 here. If you did it the combined way, 0.5 molar equals 40 divided by 58.44 over L. So 40 divided by 58.44 divided by 0.5, 1.37 liters, 1370 milliliters. Do the way that works best for you. So if one of these is overwhelming, do the other one. Yeah? Both of them get you the exact same answer, as you can see. And both of them are valid ways of solving this. Questions? All right, so that is it for molarity. If you want to click on the next video to watch dilutions, then go ahead. But if all you needed was molarity, have a great day, and I will see y'all later.